All right, section 6.3, central limit theorem. So this is like the first time we've had the actual theorem of statistics, okay? It's in capital letters, everything you know is supposed to be important. All right, but this isn't a class in theory. It's not like I'm going to make you write a proof. It's not even like I'm going to have you state it, but you kind of need to know what it is. So here's this bell curve. And let's say it's the age distribution of all the students who go to Palomar. So some are really quite young. Some of them are like returning adult students. It's really spread out. It's not like everybody's 18, 19, and 20. But there's some mean age right there, right in the center, right? At most bell curves, the mean is going to be right in the center. And the thing is, I don't know it since I can't really interview everyone that's on the campus. Right now, there's no one on the campus. But even if I could, I still couldn't do it. I couldn't get a hold of all the students. So what I could do is I could grab a student out of our class, if we had a classroom, and I could send them out and say, hey, go, quick, grab 2 students and find out what their age is. Okay, and maybe they come back and they say, well, I grabbed 2 students and then I averaged their age and I got like 19.2. And then I go, well, yeah, but it was only 2 students. I don't even know if that was right. Why don't you, different student, go out. Why don't you get a number? And they go out and they get like 18.4. And I go, well, now I got 2 different answers. I don't even know what to do. And I send somebody out, and for some reason, they end up with 23.5. And somebody else finds some young students, and they're over here. But if I sent everyone in the class out to get some kind of answer, probably no one have the same answers as each other, but their answers would start bunching up around the center. Okay, and basically it would kind of look like a bell curve by itself. All these people bunched up in here and some people out here. And what it says is that if you ask enough people and do enough little studies and, you know, these little meta studies of studies on studies, you're going to end up pretty much at the mean. We know it's in there somewhere. We know that there's something like this going on. Okay, we don't know the exact shape of the curve because we still didn't talk to every student, but we know it's in there somewhere and we know the mean is around there somewhere. And if you do enough of this, you will eventually get to the mean. Okay, so this is a bell curve too because it looks like one. It's not exactly the same as the other bell curve. It's squished in. Okay, standard deviation on this, because it's kind of spread out, maybe the standard deviation, that would be like 2 standard deviations there. And maybe 2 standard deviations here is squished in a little. Okay, so you hear things said like this, oh, sooner or later everything is normal. Okay, what it's saying is that even if this curve hadn't been normal, this curve is always normal. I'll try and see if I can't get to the mean curve if we have a bunch of people doing it. That is always a normal curve. And more than that, the mean of this one is going to be exactly the same as the mean of that one. So maybe no one's mean was correct, but the mean of all of our means is actually the mean. And the other thing we could say is that the standard deviation of this one is smaller than that one. So that's like the theory, okay, is, well, the mean is the same as the mean. So the mean of my little sample should be about the mean of the entire population, should be the same. And the standard deviation on this kind of thing is smaller than the standard deviation on that. And more than that, we know how much smaller that is. It's if the standard deviation here was like Sx, then the standard deviation down here, which is smaller, I'm going to divide by the square root of however many people I ask. So if all these people just ask 2 people, I'd put the square root of 2 down there. If I'd send each one of these people out to ask 100 people, I'd put the square root of 100 down there. It's going to really suck that standard deviation in. And that is the central limit theorem.